Welcome back. In this section, we're tackling one of the most critical challenges when deploying Gen AI in the workplace: ensuring the factual accuracy of the outputs. This competency is all about developing and implementing factuality verification systems to identify and address potential hallucinations. As Gen AI developers, we know these models are powerful pattern matchers trained on vast data. However, they don't inherently possess a real-time, verified knowledge base. This technical limitation means they can generate outputs that sound convincing, but are factually incorrect, a phenomenon we call hallucination. For workplace applications, this isn't acceptable. Deploying AI that fabricates information undermines trust, leads to flawed decisions, and can have serious consequences depending on the domain, from legal to financial to operational. Building trust requires that the AI we deploy is reliable. This is why building factuality verification into the Gen AI development pipeline is essential. It's not just a post-processing step. It's a core part of developing trustworthy AI applications. The fundamental technical challenge in fact verification, beyond simply relying on the initial data source, is the programmatic validation logic. How do you automatically compare a statement generated by the AI against a known, trusted source to confirm its truthfulness? Consider a generated sentence like, "Project Alpha was completed on October 26, 2024, resulting in a 15% cost reduction." A verification system needs to technically process this. First, it must extract the verifiable claims from the natural language output. This often involves using natural language processing techniques like named entity recognition to identify entities: Project Alpha, October 26, 2024, 15%, cost reduction, and relationship extraction to understand the relationships between them. Completion date for Project Alpha. Result of completion for Project Alpha is cost reduction of 15%. Second, the system needs to be able to access and query trusted sources of truth. These sources might be structured databases like a project management database or a financial system, internal documents stored in a knowledge base, or external APIs providing verified data. Third, and this is the core technical step, the system must programmatically compare the extracted claim against the information found in the trusted source. For structured data, this might involve querying the database for Project Alpha completion date and Project Alpha cost reduction, and comparing the return values to those generated by the AI, handling data types and formats. For unstructured sources like documents, especially when verifying AI-generated citations, the system might use techniques like natural language inference, NLI, or entailment models. These are specialized models trained to determine if a piece of text, the AI's claim, is supported by, contradicts, or is neutral with respect to another piece of text, a sentence or paragraph from the cited source. Does the source text logically entail the claim made by the AI? As developers, implementing these systems involves tasks like integrating the Gen AI service with various internal and external data sources via APIs or database connectors. It requires choosing or building the appropriate NLP and ML models or rule sets for claim extraction and comparison. It means designing the workflow to integrate this verification step into the inference pipeline, perhaps running the verification logic immediately after the Gen AI model generates its output. We also need to define how the output of the verification step is handled. Is it a simple true/false flag, a confidence score, or does it highlight the specific parts of the output that could not be verified? Key considerations in workplace implementation include the technical overhead of running these checks, adding latency to the response, managing access to diverse and potentially sensitive trusted data sources, and the complexity of verifying subjective or highly nuanced outputs programmatically. Integrating the verification service seamlessly into the existing application architecture is also a development task. Limitations are inherent. Verification systems can only check against the data sources they have access to. They may struggle with ambiguous language or facts that change rapidly. Building and maintaining the complex validation logic can also be resource-intensive. Ultimately, for Gen AI to be reliably adopted in the workplace, developers must build trust into the system itself. Creating sophisticated factuality verification systems, understanding the technical challenges of comparison logic, and integrating these into the deployment pipeline are critical responsibilities in Gen AI development. It's how we move from generating plausible text to delivering trustworthy information.